It's now time to look at post-processing and analysis in the third part of this video. I'm going to be using the sequencer within SharpCap Pro to guide me through the post-processing and analysis phase. I have written a script called Generate Light Curve that will run me through all the steps necessary to get from my raw data through to a processed light curve. Now, the screen may get fairly busy at times here, and normally I would use the software across two screens as it's somewhat easier. But for the purposes of this video, I'm going to do it on a single screen. So I start my sequence, and the first thing it asks me to do is to install the daily update for Astro Image J to ensure that I'm working with the latest and greatest version of the software. The sequence automatically opens Astro Image J. I go over to Help and Update. And the program now reaches out to the main server and downloads the latest daily build. Now, the sequencer is now asking me to go to my raw images and copy those from a science folder to a processing folder. And I'm going to use some data I collected a couple of nights ago for V576 PEG. I'm going to open that data up using File Explorer. And here is the raw data that I collected. So the first thing I'm going to do is create a science folder. And I'm going to create a quarantine folder. And then I'm going to create an AIJ processing folder. And I'm going to take all of the raw images that I've collected, and I'm going to put these in the science folder. And apart from copying them into the processing folder, these will now remain untouched and get archived in case I need to do later analysis. Okay, so they're in the science folder. So I'm now going to copy them again. And I'm going to place them in the processing folder as well. So all of the files have now been copied across to the AIJ processing folder. So I'm going to go back to SharpCap. I've now completed this stage. And it's now going to ask me to open the 146 images and visually inspect them with the AIJ tool and quarantine any bad ones. So let's open AIJ. I select just the first file, press open, and a dialog box will come up and it will show me that I'm about to import 146 images from this run. Okay, so those images are now imported. I'm just going to vary the white and dark levels here so that I can clearly see the stars. And if you remember from our image that we looked at on Aladdin 10 earlier, this is our target star here, V576 PEG right in the center of the image. And I'm now just going to quickly step through these images by moving the cursor across. And you can see that the image is drifting a little, even though we had guiding on. But all of the images look pretty similar, particularly if we look at the histogram on the bottom. The histogram is not really changing as we move across. So it looks as though we don't need to quarantine any images. Okay, so I've done that process. I don't need to quarantine anything. I can close down AIJ. And now the sequencer opens up ASTAP, which I use for two purposes. The first of those is to do a batch plate solve. And to do that, I'm going to go into Tools, Batch Processing, Batch Solve Images. I am going to go to my data that I'm processing. I'm going to select all of the files which I wish to batch process and open. And immediately you'll see that the ASTAP is doing a batch solve of all of those images. And it typically takes about half a second to solve an image. It's one of the reasons I like ASTAP as a tool. The plate solving is extremely quick. And what's happening here is the image is coming in. Its center position is being determined. RA and DEC is being calculated for that. And those coordinates are being written back into the FITS file header for each one of the images. Now, what's interesting is that not all of these images will solve, and that will create a problem. And so we will need to go in and take a look at all of the images and just step through them and make sure that the WCS header has been updated. And if it's not, we will quarantine the images. And one of the reasons that I believe that some of these images won't solve is because if you've got multiple targets or multiple objects moving through your field of view, such as satellites, we have a lot of military traffic here, that can upset the plate solver. We will do the next item in our sequence that I've written, which is to either do 2x2 binning, reducing the source file from 3008 by 3008 down to 1504 by 1504, or we will extract one of the color pixels. And in fact, we're going to do the latter. We're going to extract the green color pixel, and that will automatically reduce the resolution down to 1504 by 1504. So, having done the batch plate solve, I'm now going to extract the green color pixel. And to do that, I go into Tools, Batch Processing, Raw Color Separation, and I am going to pick the 1-2 pixel, which is one of the two green pixels. And it's going to ask me which images I want to process. And it's now going through. ASTAP is now going through and selecting the 1-2 green pixel and creating a new image file that we'll see in a few moments. Again, this takes about half a second per image. So we have about a minute to wait now as this processes. I typically select the green channel because green channel results obtained with a color CMOS camera are actually very accurate or very similar to results that you achieve with a monochrome camera, and a Johnson V filter. But I could have just as easily selected the blue channel or the red channel if I was interested in looking at the data in that part of the spectrum. And I've done my batch plate solve. I've also done my color extraction. So now I go back into the File Explorer, and you'll see now that I have got two types of file here. I've got the raw file that was plate solved, and then I've got the extracted P12 file, which of course is also plate solved, but is considerably smaller because it's only a 1504 by 1504 image compared to 3008 by 3008 for the 533 MC color camera that I'm using. So I'm now just going to order these files according to size, and I'm going to select the larger ones. I'm going to delete them. And this is why we do all of our work in a separate file outside the science folder, because if you were working in the science folder and you did this deletion and it was by mistake, you might have a problem recovering the files. But by having a science folder, which has got your original files, you can always go back to those files if any of the data is corrupted during the processing of it. So I'm going to delete those, and now I've got 146 images that are all 1504 by 1504. Okay, so now the sequencer opens up AIJ, and I am going to import the green channel images in 146 of them. And you can see that the first image, which is what we'd hoped for, has got the RA and DEC coordinates written in the FITS header. And as I mentioned earlier, if the plate solver failed to plate solve, these RA and DEC will be empty. So we need to go through and we need to see if there are any files for which the plate solving failed. We're going to just have to do this manually using the arrow key. So I'm going to step through each one of the files. Just make sure, there we go. There's one. So we need to remove image 44. Okay, so we've just found the one image that did not solve 44. So we're going to go into the File Explorer again. We are going to go to our images that we're working on. We're going to go to image 44. And I am going to cut that image out. And I am going to paste it into the quarantine section. Okay. So we are going to now re-import the file because I need to make sure that that import doesn't contain the raw file, including the one that's got the missing WCS coordinates. Okay, and we're going to import 145 images this time. Okay, and just quickly scanning through again, everything looks like it's okay. But we still do have this issue where, as you can see, over time, our target star is moving across the image. But we're going to sort that out next. So now in the sequencer, my next step is to align the images using either the WCS coordinates or by placing an aperture over the target star. And I'm actually going to align using the WCS coordinates, which is why it's important to make sure that I've got no files with missing WCS coordinates, because at that point, AIJ will actually stop processing the images. So going back in, here are all my images. I've got 145. I'm going to go into, where am I going to go here? I need to process a line stack using WCS or apertures. I've got my 145 images. I'm going to use the array and deck to locate. I am going to use only the WCS coordinates within the header for the alignment. I'm going to have these checked, and I am going to press OK. And AIJ now is going through the process of aligning all of the images using the information in the fits header. Okay, great. We have done that. And AIJ has now written these aligned images to a subdirectory called aligned. So these are the images that we were working on. As you can see, these are the unaligned images. And in a minute, we'll look at the aligned images. So we've gone through that. I'm going to press OK. Now it's going to ask us to, within AIJ, import the aligned data. So I'm going to go back into AIJ. I'm going to do File, Import, Image Sequence. And here is that subdirectory called aligned. And I'm going to select the first image, 145 images. And as you can see now, when I move across all of the images, the target star now stays stationary because we've aligned the images according to the WCS coordinates within the fit set. Okay, so we've essentially now finished the post-processing activities using ASTAP and AIJ. We're now going to actually generate a light curve. And to do that, we're going to use a function within AIJ called the DP, or data processing. And I'm going to go into the DP. And running the DP will open two windows. The first window is this one. And the important things here are to make sure that our observatory location is correct, along with the altitude of the observatory, and that our target star is selected here. And as you can see, it's already populated with V576 PEG. And that will ensure that when we do such things as air mass calculation, etc., that all the information that we get is correct. So this window is okay. I'm then going to go into the second window. And now I have to make sure that I process the right data. And as you can see at the moment, this is the data for the 14th of September. We were working on the data for the 15th of September. So I'm looking at the wrong data at the moment. So I'm going to go into the folder option. I'm going to go to my working folder. I'm going to go to my working folder, which is this one. And I'm in the right folder, but now I've got to set up the file name here with appropriately positioned wildcards to ensure that I bring in all the files that I'm trying to So if I make that modification and have the wildcard here, you can now see the 145 images that I want to process have appeared here. If you were doing dark frame, bias frame, flat frame, correction of the image, this is the point that you would do it in post-processing. But if you remember from segment 2 of this video, we actually did that during the image capture process. So I don't need to do anything here. I will then go down, just check what else we have here. We are not going to save any calibrated images. We are just going to go through the generation of the measurement file. Now you can do the generation of the measurement file and also do the plot at this point, but I find it's better to just generate the measurement file and then initiate the plotting function. So we're going to have this box checked and this one unchecked, and we're going to click start. All right, and the first thing that's going to happen is that we're going to need to place our apertures on our target star and comparison star. These figures, these numbers here correspond to the aperture, the size of the ring, and the outer size of the annulus that allows us to look at the background. And I had, prior to starting the video, or started recording this part of the video, checked one of the science files to make sure that these are the appropriate numbers. And I am going to place my apertures with these checkboxes checked. So here is my field of view. Here is my target star. So this is going to be the first star that I select, and that's going to be labeled T1. And all of the remaining stars that I now select are going to be my comparison stars. And I always select 7 comparison stars so that I'm looking at 8 stars in total. And I'm just going to look around here. I've got a number of stars here. I'm just mousing over them to check the peak value is not saturated. And I can see that I've got some good targets here. This one up here. This star is saturated. You can see the peak value is at 65,535. So this would not be a star that you would wish to select as a comparison star. So I'm going to pick now a random selection of 7 comparison stars. 1, 2, 3, 4, 5, 6, 7. So in total, I have selected 8 stars. And these are going to be the ones that we're going to do differential photometry using. We're going to be using the comparison stars to do differential photometry on the target star T1. Okay, so with my apertures placed, I'm going to hit return. And we are now generating the results for each one of the images that we collected. So 145 images, and we're stepping through those. We can actually see the air mass column here. You can see that the star was rising in the sky as the air mass number is getting lower over the period of these measurements. Okay, great. So we've done that. So we are going to minimize that. And we're going to go back into our sequencer. So I've run the image through the data processor. And now I am going to plot that data. So I go back into AIJ. And I select the plot button. And at this point, a whole sequence of windows is going to open on my screen. This can be a little intimidating for the first-time AIJ user, as there's a lot of information in each one of the windows that's opened. But I am just going to step you through the opened windows. And to do that, I'm going to minimize some of these windows so that we can bring them up individually. So we're going to go in and we're going to look at a couple of these plot files. The first one is the multi-plot file. And within the multi-plot file, I want to make sure that I've got the name of my target written in correctly. I want to put a subtitle in, which is for the green pixel. I want to auto range, which I've done here. That all looks pretty good. And then I'm going to open up another. This window is interesting. This window tells us for the measurements that we're doing, which of the comparison stars we're using. And at the moment, we're using all of the comparison stars, C1 through to C8. Now, that may not be a good choice, depending upon the quality of the comparison star. So the next thing I'm going to do is go into my multiplot Y window. And essentially, this is a pre-set-up template. And I'm going to plot the relative flux of the target star and the comparison stars. And I'm going to do that in such a way that I can look at the data and quickly determine if my comparison stars are good quality. And you can set up templates for what you want to plot, what color your lines want to be, whether you want to put lines on, whether you want to just put dots on, whether you want to smooth the lines, etc., etc. And you do this all within the multiplot Y window. And so that brings us to our final window, which you actually got a glimpse of a couple of minutes ago, which is the plot window. And I am now going to take a look at this window, and I can tell you straight away. And again, it's kind of a little difficult dealing with just the amount of limited space that we've got here. I can tell you that we've got, this is our target star, the 576 peg, and as you can see, we've caught it when we did this measurement run, we caught it pretty much at the peak of its light curve. It then faded approximately 0.6 of a magnitude, went through a minima, and then came out on the other side. And I've got multiple comp stars here. You can see the first couple. Comp star 2 is actually very stable. Comp star, the second comp star is not quite so stable, but it's pretty decent. And here is the final plot of the light curve that I collected on the evening of the 15th of September for the 576 peg. This is a relative flux curve, but by selecting the right checkboxes, I could be displaying this in absolute magnitude as well. So that is a quick overview of the post-processing of data associated with the variable star within AIJ, or at least the processing of that data. We did the post-processing of the raw images in a combination of ASTAP and AIJ.